We're going to take a look at solving or simplifying expressions with complex numbers. A complex number is an expansion of the real numbers where you can end up taking the square root of negatives. Basically, it boils down to whenever you have a negative underneath of a root, you end up having an I. By definition, the square root of negative 1 is defined to be I. In other words, if you're looking at the square root of negative 4, it's really the square root of a 4 times a negative 1. Since it's multiplication inside, you can apply the square root to each one. The square root of your 4 is your 2. Square root of negative 1 by definition is I. So in other words, you get 2I. You could think of it as, well, the square root of 4 is 2, and if I have the square root of a negative, I just have to have an I hanging around. It's going to give you the same answer either way. Complex numbers are typically written with a real part, a part that has no i's, like the 5, plus a part that does have an i's, that's like the 2, since it has the I hanging about it. So the imaginary part's referred to as the 2I in this particular number, and the real number is referred to as your 5. Now, with complex numbers, you're going to also have to be dealing with conjugates. Remember, conjugates are when you just switch the sign in between the real part and the imaginary part. We've talked about conjugates before. So here, this is your conjugate. If this is your original problem, you switch sign in between, here's your conjugate. If this is the original problem, you just switch the sign in between, and then that's your conjugate. So in simplifying these roots, it's going to be just like we were doing before, but since we have a negative inside of your root, you're going to have an I end up hanging around in your final answer. So we're going to start off by rewriting this as a negative 1, a 32, and in y cubed. So that negative 1 will just leave hanging around. You know 32 is 2 to the 5th, and then you have your y cubed. Your negative 1, since you have a square root, let's write things as something squared. So a 2 squared, a 2 squared, and a 2, a y squared, and a y. So the square root of that negative 1 is I. Square root of your 2 squared is 2. Square root of your 2 squared is 2. Can't do anything with that 2, so it's got to stay inside your root. Square root of your y squared is y. Can't do anything with this y because it's not a squared, so it stays inside of your root. So in front, we're going to just get a 4yi. Typically, the I goes at the end. Does it have to? No, because it's multiplication. You can multiply in any order you want, but it's kind of standard practice to put the I at the end. But I don't like to put it after the root because if you're a sloppy writer, sometimes it'll look like the I's inside the root instead of after the root. So I put it at the end of what's in front. Same idea over here. Write it as negative 50, or negative 1 times 50. You know 50 is a 25 times 2. So the square root of your negative 1, square root of your 25, square root of your, oops, sorry about that, square root of your x squared and square root of your x squared leaves you with your 2 here and your x still inside of your root. So that simplifies down to 5x squared I with the square root of 2x. When you're multiplying roots with negatives in them, you must simplify them first so that you can ensure to get the correct answer. So this is a negative 1 times 12. This is negative 1 times 2. You know 12 is a 4 times 3 because we want to look for factors of 12 that are perfect squares so that we can simplify it. So we're going to get a 2i, the 2 from the square root of the 4, the I from the square root of the negative 1, still leaving you with a 3 there. Over here, we have this still, didn't change, but the square root of your negative 1 is an I, so we'll pull that in front. Square root of your 2 can't do anything with. So now that we have it simplified, we can multiply them together. Multiplying them together, we multiply what's in front. A 2i times an I is a 2i squared. Multiply what's inside, you get a 6. So you get the square root of 6 here. And now we really get 2 times negative 1. You might be wondering why. Well, taking a look over here, we know by definition the square root of negative 1 is I. If we square the left side, square the right side, you know squaring the left side undoes your root, so it leaves you with just a negative 1. So an I squared is also defined to be negative 1. So in other words, over here, it's really just a negative 2 times the square root of 6. Powers of I. We know we just talked about this. This is really an I squared times an I, so it's a negative I. This is an I squared times an I squared, or a negative 1 times a negative 1, which is a 1. This is really just an I to the fourth, which is 1 times an I, so it's an I. This one here is an I to the fourth times an I squared. I to the fourth is 1. I squared is negative 1. And then this pattern continues on here. In other words, if your exponent's a multiple of 4, you're always going to get a 1 when it's an I to a multiple of 4. If your exponent is 1 more than a multiple of 4, and that's what we're saying with this plus 1 here, you're always going to get an I. If it's 2 more than a multiple of 4 like these, and that's what we're saying with the plus 2, it's always a negative 1. If it's 3 more than a multiple of 4, then you always get negative I. So in simplifying these, is I to the 37th a multiple, or is 37 a multiple of 4? No. It's 1 more than a multiple of 4 because 36 is a multiple of 4, so you get I. Is 16 a multiple of 4? Yes, so then you just get 1. Is 43 a multiple of 4? No, but 40 is the closest one underneath it, and it's 3 more, so if you're 3 more than a multiple of 4, you get negative I. Oops, that's supposed to be negative I, not negative 1. Sorry about that. And so, we look at the next one here. We end up now looking at this. This is 1 more than a multiple of 4, and so we get I. Well, we're going to just multiply the numbers. Negative 1, or negative 3 times 2 is negative 6. Your I times I is I squared. You know I squared is negative 1. Negative 1 times negative 6 is 6. Same idea here. Multiply your numbers. Multiply your i's. I squared is negative 1. 15 times negative 1 is negative 15. And this we did on the previous page. I'm not sure why I listed it again. So here, all we're going to do is distribute through the minus sign into the second parentheses. And then we're going to just collect like terms. Your 4 and your 3 gives you your 1. Your negative 6i plus your 7i is this. Here, since it's adding in between, you don't need the parentheses. Just collect your like terms. Your 3 and your negative 2. Your 2i and your 5i is 7i. Now, if you end up having two complex numbers that are equal, really, all you have to do is look at the real parts and the imaginary parts. Consider this over here on the right. If we have two complex numbers that are equal, the real parts have to be the same, and the imaginary parts have to be the same. You'll see the imaginary parts are, so therefore the real parts, the a has to be 3, and that's what we're saying here. These two complex numbers are the same, so the complex parts have to be the same, and the real parts have to be the same. You'll see the real parts are, so your 4 has to be equal to c. In other words, if two complex numbers are equal, the parts that have i's have to be equal, and then the parts that don't have i's have to be equal. So in other words, the parts that don't have i's are these here. They have to be equal. And then the parts that do have i's also have to be equal. And really, it's just the parts in front of your i's that has to be the same. So as we look here, the parts that don't have i's has to be equal. You can solve that and you get 4. The parts that do have i's, you set what's in front equal to each other, and then you can solve it from there.